So, hello everyone. Today we are going to solve the coin combination 1 from CSES problem set. So, let's have a read. Consider a money system consisting of n coins. Each coin has a positive integer. Your task is to calculate the number of distinct ways you can produce a sum money x using the available coins. So, you have to calculate the number of distinct ways. Number of distinct ways for to construct sum money x. And you have the coins C1, C2, C3, C4 up to C, right? You have to construct the sum of sum money x. For example, if you have the coins 2, 3, 5 and you have to construct 9, so there are possibly 8 ways to construct it. That is this, right? Now, one thing to note that it asks us to find out the number of distinct ways, not the distinct ordered ways, right? What do you mean by this? You can see that here the number of coins you are using, that is similar, right? For 2 to 5, for 5 to 2, you are using the similar coins, but the order is different. So if the order is different, it is considered to be a different in this question, but in coin combination second, the number of distinct ordered ways, you have to find the number of distinct ordered ways. So this considers one way. That is, order doesn't matter. You have to find the number of distinct ordered ways in combination second. But in this way, uh, this is considered as a different cases, right? So let's try to get the intuition how we can solve it, right? First of all, think about the very smallest problem that you can solve. You have the coin 2, 3, 5, and you have to calculate, you have to construct the sum 9. First of all, think about the very small problem that you can solve. What it can be? It can be the construct the sum of money 0, right? Now, in how many ways you can construct the sum money of 0 if you're having the coin 2, 3, 5, right? So there is only one possible way, that do not take any coin, right? Do not take any coin. That is the one possible way. Yes. Now, what will be the answer for F1? That is 0, because you have not any coin whose value is 1. Whose value is 1. If you have a coin 2, 3, 5, you cannot take any coin, right? So for the 1, the answer is 0. For the 1, the answer is 0. Now, let's make the array and store this result in answer, in this array. For 0, the answer is 1. For 1, the answer is 0, right? Now, let me ask you a question. How can you construct F2? How can you construct F2? Right? How can you construct F2? So you have the coin 2, you can take it. If you are going to take it, now next what you have to construct. So for F2, this is the sum that you are going to construct. Now this is the coin that you are taking. Now next you are going to construct 0, right? Now you can already calculate it. That is, there is one way to construct a 0, right? There is one distinct way. So for 1, for 2, the current sum is 0. You found it that if you are taking the coin 2, you have to add it in, suppose this is our DP table. Here this is DP array. So you have to add it, right? You have to add it DP of 2, right? And instead of F, we can use DP, right? So the answer for F2 will be 1. The answer for F2 will be 1, right? Now, we cannot calculate for 2 and 5 because it doesn't contribute to our answer, right? So let's take the example F3. Now you can use the 2 coins, that is F2 and F3. If you are using the coin F2, next you are going to construct 3, right? Now, there is 2 observations that I can make. That is, if coin is less than equal to sum, then you are going to take it, right? And next, you have to calculate for sum minus that coin. Sum minus that coin. So sum minus that coin, if you are using the coin 2, next you are going to construct for F1. For F1, you are already calculated, that is 0. So now for 3, current is 0. You found it that there is 0 ways if you are taking the coin 2. Now, if you are taking the coin 3, Next, we are going to construct 0. There is one way to construct, so this is going to be 1, right? Now, let's calculate it for F4, F5, F6, F7, F8. This all help us to find out the number of distinct ways to construct 9, right? I have to calculate for F4, for F5, for F6, for F7, for F8, and this all help us to find out the number of distinct ways to construct many sum of 9. So for F4, calculate along with me, calculate it. For F4, you can use the coin 2, you can use the coin 3. You are not going to use coin 5, right? That is, it is greater, thus greater than the sum. So for 2, next problem that you are going to solve is 1. So current is 0, current is 0. So for F1, if you are taking the coin 2, next you are going to construct F2. So for F2, the answer is 1. So 0 plus 1 is 1. For F2, for F1, you already calculated it, it is 0. So 1 plus 0 is 1, right? Now let's calculate it for F5. For F5, you are going to take all 3 coins. You are going to take all 3 coins. F5, 5 minus 2, 5 minus 3, 5 minus 5. If you are using the coin 2, next you are going to construct is sum minus coin, that is 3, then 2, then 0. The answer for 3 is 1. The answer for 2 is 1. The answer for 0 is 1. So for 5, 1 plus first one, then 2, then 3. We add it, right? We traverse the coin and we found out if we are using the coin, the answer will be dp of sum plus में dp of sum minus coin. That is dp of sum is dp of 5, dp of 5 is 0. 0 plus sum minus coin is 1. So 1 plus 0 is 1. Next, you going to the coin 3, going to the coin 3, then it is going to be dp of sum, that is 5, plus sum minus coin is dp of f2, dp of 2, dp of 3 is 1. So dp of 5 is 1 now. So 1 plus 1 is 2. So it is going to be 2. So 2, then 3, right? Similarly for f5, for 5, if you are using the 5, the answer is updated to 3, right? This is how it how it works, right? You have to calculate for f6. You can use the coin 2. If you are using the coin 2, you are going to construct f4. Then if you are using the coin 3, then you are going to construct f3. Then you are going to construct f1. So for 4, the answer is 1 plus 1 plus 0. It is going to be 2, right? For 7, if you are using the coin 2, then you are going to construct 5. If you are using the coin 3, then 4, then 2. So for 5, the answer is 3. For 4, the answer is 1. For 2, the answer is 1. So 3 plus 2 is 5. So the answer is 5 for 7. Now if you are going to for 8, if you are going to use coin 2, next you are going to construct f6. For 3, 5. For 5, 3. So 6, for 6, the answer is 2. For 5, the answer is 3. For 3, the answer is 1. So for 3 plus 2, 1 is 6. So for 8, the answer is 6. Now let's calculate for 9. If you are using coin 2, then you have to construct 7. Then you have to construct 9 minus 3, that is 6. Then you have to construct 9 minus 5, 4. For 7, the answer is 5. For 6, the answer is 2. For 4, the answer is 1, right? So the answer for 9 is 8. So ultimately, you have to return the dp of sum, right? For ultimately, you have to return the dp of sum or dp of x, that is x, right? X. So this is how it works. You have to construct, you go through the all coins. If you are taking this coin, then you have to construct for this sum minus coin. That is, you already calculated previously. You are using it and you filled your dp array. Then at the end, you will find your answer, right? So let's see the code. So let's discuss the code. We have a n number of coins and x is the sum that we have to construct. Let's take the input and x. Let's define the coin vector coins of size, and let's take the input I and I equals to 0, I less than I plus plus sin coin I. Okay, now we have to define our vector dp vector x plus 1, initialize it with 0, and we have to initialize our dp of 0 equals to 1. Then for sum into sum equals to 1, sum less than equal to x, sum plus plus. Then we have to traverse for all the coin. Now, if coin is less than equal to sum, then we have to consider it and we have to update our dp of sum. So plus equals to dp of sum minus coin, right? So this is the update transition that we have to do, and yes, and we have to print our dp of x, right? Sum minus coin. So yes. So let's get the input, that is number of coins 3, we have to construct 9, we have the number, we have the coins 2, 3, 5. So let's try to run it. Yes, so the number of ways are 8. So this is the code. I hope you got this. Thank you. Let's 1 second, we have to discuss the time complexity also. So the time complexity is big of O x, sum x into n, right? X into n. Okay, this is the time complexity, and the space complexity we are using the derivative space of x plus 1. Okay, thank you.
Until we reach it, all you need to know is that we're holding on. We rise up from the dust and claim our throne.